Question 10, I can see this one is coming from differentiation. The gradient of a curve at the point, this one, is given by this expression. The curve has a stationary point, this one here, where a is a positive constant. Then find the value of a. Of course, the first thing we do is to equate this one to 0. So for stationary points, we know that dy dx is equal to 0. So x is equal to a, because this is a stationary point, so x is that a. Now I will say wherever there is x here, I'm going to substitute it with an a. So we shall have 2 into a plus 3 to the power of a half, then minus a will be equal to 0. Then I'll have 2 into a plus 3 power half. Take this one, this other side, and then from there we square both sides. So square both sides of the equation. When I square this one, of course it will be a plus 3. And then when I square the 2, that one will be a 4. And then here a squared. So I'll take everything this side. We shall have a squared minus 4a when we open the brackets, then minus 12, which is equal to 0. Now, two numbers, when I multiply them, they give me negative 12, but when I add them, they give me negative 4. We can see negative 6 and then positive 2. So that means we shall have a plus 2 here, and then a minus 6, which is equal to 0. So meaning that a is equal to negative 2 and also a is equal to positive 6. But since they say that a is a positive constant, that means I'll take 6 as my final answer. Then next, part B, determine the nature of the stationary point. That means we have to differentiate the second time. dy dx here, we see it as 2 into x plus, this is 2 into x plus 3. Is it x plus 3? Yes, then to the power of a half, then minus x. That means the second derivative here, the 2y dx squared, is going to be 2, then times, drop this power. So we shall have a half into x plus 3, then reduce the power by 1, that will be negative a half, then times, enter inside here and differentiate, you will get a 1. And then here, when you differentiate this, you will get a 1 here. So meaning we shall have 1 over, of course, this one is 1. So 1 over the square root of x plus 3, then minus 1. Now, at the stationary point, remember a is 6, and then the y coordinate is 14. So 6 and then 14. So the x coordinate here is a negative, is 6. So 1 over the square root of 6 plus 3, that is a 9. Square root of 9 is 3. So a third minus 1, that is negative 2 over 3, which is less than 0. So that means the nature of this stationary point is maximum. Okay? Because if this one is a negative, that is a maximum point. If it's a positive, it's a minimum point. But C, find the equation of the curve. That means we have to integrate dy dx, okay, with respect to x. So what is our dy dx? Our dy dx is this one here. So it is 2 into x plus 3. 2 into x plus 3 power half, then minus x here with respect to x. So that means our y is going to be 2 into x plus 3. Increase the power by 1, that will be 3 over 2. And then here you also divide it, then times the derivative of this one, which is a 1. Then plus, of course, it's a minus. Then x, increase the power by 1, divide by that new power. Then plus c. We need to put that arbitrary constant because we don't know the constant which was differentiated and then disappeared. Now this one simplified, this one will somersault and go up. then we shall have 4 over 3 into x plus 3, then 3 over 2 as the power, and then minus a half of x squared plus c. So we need to get a point that is on this curve. If a point is on the curve, that means its coordinates are satisfying the equation of that curve. And we have seen that stationary point is on the curve. So that is 6, 14. So where there is y, we are going to put 14. And then this is 4 over 3. Then here we shall put 6 plus 3. Then 3 over 2. And then minus a half. This one here is going to be 6 squared, then plus c. Now this is 14. This is 9. The square root of 9 is 3. Then 3 power 3, that will give us 27. 27 divided by 3 will give us a 3. No, will give us a 9. 9 times 4, that is 36. So I'll bring this one here as 36. And then this one is 36 divided by 2. That one will be 18. So when it crosses, it's a positive. And then this one will be equal to c. So 18 plus 14, that one will give us 32. So 32 minus 36, that is a negative 4. So therefore c is equal to negative 4. So the equation of the curve is therefore going to be y, which is equal to 4 out of 3 into x plus 3 to the power of 3 over 2, then minus a half of x squared, then minus 4. That is that.